I want to do a very brief introduction to, or maybe a review to, basic relays, the operation of them, and some real simple wiring of a basic relay. I know some of you may have already worked with relays in the fundamentals class. Some of you may have not. So this will be a very short little lesson in relays. So what is a relay? It's basically an electromechanical device that performs the exact same function as a switch. However, it takes advantage of electromagnetic principles to change the state of a set of contacts. So when a control voltage is applied to a coil, the coil produces an electromagnetic field, which produces an electromagnet, and that electromagnet attracts a set of contacts, or the wiper of the switch, and changes the state of those switch contacts. So why do we want to use a relay? Why not just a switch? Well, relays have an advantage of being a switch that, one, you can control by a low voltage source while you're switching high voltages and or high currents. So I could control a relay using a 24 volt DC signal, but I could be switching 220 volts AC or 480 volts AC. Relays can also be controlled by electronic controllers, such as programmable logic controllers, PLCs. PLCs cannot handle very large voltages and currents. Currents are usually restricted to 1 to 2 amps, and voltages DC maybe up to 48 volts, AC up to about 120, where if I have a programmable logic controller that is also controlling the coil of a relay, now I can have the PLC switching much higher currents, much higher voltages. And just as a form of terminology, relays that handle high current and or high voltage are usually referred to as contactors. So relays have several parts, and the main parts of the relay are a coil, a movable armature, which when we talked about switches we called it a pole or a wiper, and also a set of contacts. So the coil is nothing more than a coil of wire that we are going to apply a voltage to that forms an electromagnet. And that electromagnet is what changes the state of mechanical relay contacts. The movable armature, which is the same as the pole of a switch, is a mechanical piece of apparatus that is spring-loaded and pivots on a hinge to change the state of the mechanical relay contacts. It is also the part that is attracted to the electromagnetic field of the coil. And the contacts, which are fixed in place, are what the movable pole makes and breaks as far as contacts when the electromagnetic field moves or pivots the pole either to the open contacts or to the closed contacts. So this presentation is going to have two videos embedded into this one, and if you're going to be viewing these slides in PDF format, and I do have them posted in Blackboard, so you can watch them or view them in a PDF format. Underneath the videos you'll see a hyperlink, and all you have to do is click on that hyperlink, and that's going to open a web browser on your computer and direct you to YouTube. Now, as a note, the first video does not have any audio. There's moments, when there's a lot of text on the screen. So you could just pause the video if you want so you can finish reading the text. But it's a really nice video. It was well done. That shows you in real basic line diagram schematics how a relay works. And then the second video does have audio, and it's a young woman who is showing you physically how the relay works. After the videos, we'll come back to the slide presentation. So here's going to be the first video, and it's going to talk to you about how a relay works. And I just clicked on the hyperlink, and I'm waiting for my web browser to launch. So that was that particular video, and I hope that helped you a little bit. And here's the next video, and it is showing you audio. And just as a reference point, you can see on this one, here is the coil, and these are the connections to the wiper, to the pole. So you could see the pole or the movable armature here, and these are the fixed contacts. When this coil is energized, this movable armature will move away, because right now it's energized. You can see the LEDs lit, but this will be explained, and this will move back and forth to open these contacts and close these. So let's watch this video.
What is a relay? This is a relay. This is a relay. Yes, these are both relays. To show you, we'll use this relay. This is the relay with its cover removed. The relay consists of two parts. The white part is an electromagnet, as the name suggests. When electricity is applied, it becomes a magnet. When the first part becomes a magnet, it pulls in the arm, which is the actual switch. The switch itself has three contacts: the centre, the outer and inner. The middle one is called common, the outer one is called normally closed, and the inner one is called normally open. The connections are either open or closed. Now let's see the relay working. The relay is now wired to a safe 12 volts. When it's switched on, you will see the contacts change over. To make it easier to see, an LED has been added. When the LED is on, the relay is energized. Now a blue and green LED have been added. When the relay is energized, the blue LED is on, and when the relay is de-energized, the green LED is on. This happens because the common contact has changed from normally open to normally closed. You can use a relay to operate something large, like this light. As mentioned at the beginning, this relay is just a smaller version of the larger one. Its layout is different, but it does the same thing, only on a smaller scale. See what other uses you can find for a relay. Now you know how it works.
So now you do know how a relay works. We're going to be using an IceCube relay. They're called IceCube relays because they are in a clear plastic housing most of the time. They kind of look like a little ice cube, and this particular one is a double pole, double throw. You can see the coil here. You can see the movable armature or the wiper. You can see the two fixed contacts on this side, and there's two on this side also. This has 8 terminals on it, and it's called an octal connection, and the socket that it plugs into is called an octal socket. So there's 8 terminals around the outside, and I've enhanced these numbers so you could see where the pin numbers or terminal numbers are located on the socket. These sockets, although they may look physically different, are usually fairly consistent as far as how they have the terminals laid out. This center diagram is the wiring of the internal workings of the relay. So pin 2 and 7 is the coil, that's the electromagnet. Pin 1 is the pole of one of the switches. Pin 3 is a normally open contact for that set of contacts, and pin 4 is normally closed. And then there's another switch with terminal 8 being the pole, 6 is the normally open contact, 5 is the normally closed contact. This is also fairly standard on octal type IceCube relays. You're going to be wiring one of these relays in the next lab, where you're going to modify the circuit that we've already built to incorporate a relay. So I'll see you in the next video.